Right, pay attention please, pay attention. Guys, look here please. What do we have? Pay attention. We have two particles, P and Q, right? Are connected by light and extensive string. The string passes over a small smooth pulley, which is fixed at the top of the fixed wedge. This is the wedge, right? Top of the fixed edge wedge. Equivalent masses for both of them. One face of the wedge is rough and inclined to horizontal with 60. And this one is what? This one is what? Rough, inclined plane. Okay? The other is smooth and inclined with 30. So, what we have, P lies where on rough face. This is P. This is what? Q. What we are asked to find, acceleration and tension, right? Acceleration and tension. So first of all, we have to find the acceleration. Actually, what do we have here? We have two inclined planes, in other words, or the particle or particle P rests on an inclined plane, or particle Q rests on another inclined plane. How can we deal with the inclined plane? First of all, what I have to do?
Draw the axis.
Draw the axis. Exactly. Only 60 rough with 30 what? Smooth. What do we have? 30. This is what?
X-axis.
X-axis. This is?
Y-axis.
Y-axis. Similarly here, this is the X-axis. This is what?
The Y-axis.
The Y-axis. Clear? Now, the forces. Always tension towards what?
The pulley.
The pulley. Without knowing the direction of motion, always the tension will be towards the pulley. We have here weight, which is mg. We have here weight also, which is what? mg. Equivalent masses, right? If this angle is 30, here there is 30. Here there is what? Sorry, here 30, there is 60. Okay? This is 60, this is what? 30. What we will have also, we have normal force, this way, right? Here we have what? Normal force. Okay. Now, in order to determine the direction of friction, I have to determine the direction of what? Of motion. It's not given. Regularly, in the past papers, or even the external, right? The motion of, or the direction of motion will be given for you. But if not, we have to test. If not, we have to test. Pay attention. You can say this, or helicometer. The first thing that I will do, I have to resolve this. Here, what do we have? mg sine 60. Here, mg what? Cosine 60. Just a minute. Here, mg sine 30. mg cosine 30. Always, again, in the inclined plane, down the plane we have mg sine 30, or perpendicular to the plane mg what? Cosine 30. Now, which forces may be responsible about the movement of the system? Whom the main forces that may move them?
mg sine 60.
Yeah, mg sine 60 will pull the whole system in this direction. Either mg sine 60 will pull the whole system towards it, in this direction, sorry. Or mg sine 30, okay, right, will pull the whole system in this direction. Okay, fine. So I have to compare which is greater, mg sine 60 or mg what? Sine 30. You got the point? Any question about this? Yes.
Y-axis مش X-axis. X-axis هاي أقرب. لا قصدي هاي 60 ليش مو جاي بين الMG والY-axis؟
ما هو نفس الشيء، هي جاي بين الMG والY-axis.
هذا السؤال جاي بين Y-axis.
هاي Y-axis. صح؟ Okay, clear? Again, girls, this force, either this force or this force, right, will cause the motion. يعني واحدة منهم they will cause ايش؟ the motion. let's test mg sine 60 و mg what? Sine 30. This one will be 0.5 mg, y 0.87 what? mg, which is greater. صح? So where is the direction of motion?
Downward.
This way. This is the motion. Right? Clear? And this is actually was the question that you asked me about it with WhatsApp. Okay? So you sent me a question. Similar to this one. Similar. It's not the same. It's not the question, but actually it's very similar. Okay? So mg sine 30 pull the whole system, right? The whole system towards it. Clear? Now I can determine the friction. Where is the friction now? Where is the friction? Here. Here will be what? The friction. Again, look, where is the direction of motion here? Down the plane, صح? Where is the friction will be opposite to the motion, so the friction will be where? Upward. Any question about this? Sure? Yes.
How did you make that assumption? Energy sine 60 is greater than
I did not do assumption.
أستاذ energy sine
Sine 60.87. Sine 30.5. Yes.
Sine 60.
Sorry, sine 60. Sorry. Okay? Clear? Okay. Let's do the dynamic. F net, or use Newton's second law, in this direction equals what? ma. When we have to, for p, let's say for what? P. Okay, for p. Look, for p it will be down the plane, صح? مرة ثانية, girls. I think more than 1 month. Okay, more than 1 month. Okay, or 1 month is elapsed بس في inclined plane. نشوف in direction of motion ونحط acceleration والtension, these things. هلا motion, as what we mentioned before, motion where? Down the plane. Hey, if net down the plane equals ma. What do we have? mg sine 30, sine 60, sorry. Minus tension. Minus friction equals m times a. Okay, m times a. In order to find acceleration, I have to find what? Friction. Friction equals mu r, right? So we have to find r. R equals direct. R equals what? mg cosine 60. mg cosine 60. Any question? Okay. R equals mg cosine. Mu at dash?
0.5.
0.5. Okay, substitute here. What we will have? mg cosine, sine 60, right?
Minus t.
mg sine 60 minus t minus 0.5 mg cosine 60 equals what? M times A. This is the first equation. This is the first what? Equation. The second equation from where?
Q.
Q. Right? For Q,
Upwards.
F net where?
Upward.
Up the plane equals ma. Look, the Q is moving up the plane. There is no friction along this side. So what we will have? We will have T minus mg sine 30 equals what? ma. This is equation number what? 2. This is equation number 2. Now what I have to do? I have to add them what? Simultaneously, right? I have to add these two equations simultaneously. By adding them simultaneously, I will get tension and acceleration. Look, mg sine 60 minus tension minus 0.5 mg cosine 60 equals ma. T minus mg sine 30 equals ma. Add them together, so it's easily, t cancels out, mg sine 60 minus 0.5 mg cosine 60 minus mg sine 30 equals what? 2ma. Look, no need to know the value of m.
Cancel divided by m.
Yes, it will be cancelled out from all terms. It will be cancelled out from all terms. And I can cancel it out. M. Now you can find A easily. If we found A, we can straightforwardly find what? Tension, right? We can find what? Tension.
It's not.
What is A?
0.57.
A equals 0.57 meters per second. Meters per second. Then substitute this value with any of these equations, right? I think this one is much easier. It will be, guys, listen. Here we will find t in terms of m because m is not given. M and g, yes, you can. فشو بصير هاد t minus mg sine 30 equals what? M 0.57 what? M. So t equals 5.47 m newtons. This is the clear, guys? Yes. Yeah. But actually, in the past paper, listen. Yes, it will be given explicitly, find the tension in terms of m, or in terms of mg. Okay, in terms of what? Mg. Clear, guys? Any question? Here, I would like to add another part to this question. And to calculate the resultant force exerted by the string on the pulley. On the question, we will be frequently asked about this. Yes. Right, copy this quickly, please. Pay attention, please. Let's add another part for this question. What is it? Find the resultant force exerted by the string upon what? The pulley. For the pulley, if you remember, guys, look here, please. For the pulley, the tension now becomes in this way. This angle actually will be 90. You know why? Because look here, guys, look. 30 plus 60, 90. So this angle is what? 90. Because the total, or the sum of the angles for any triangle is 180. Hey, 30 plus 60 is 90 plus 90, 180. So here the angle is what? 90. How can I do this? By shifting one of these forces in order to have head to tail, right? Head to tail. Yeah. In other words, this is the tension. Okay? I may shift this tension here. They are equivalent. They are what? This is tension, this is tension. Where is the resultant? Look, I shifted this force only. Best, I shifted. Okay? Where is the resultant? From where?
From that
Tail to head. This is what? Resultant. If this angle is 90, this is also what? 90 as well. Total is 180. How can we find this? By cosine rule. Cosine rule, r squared or r equals square root of t squared plus t squared minus 2t cosine 90. Yes, Pythagoras, yes, you can. Pythagoras actually is a special case of what? Of cosine rule. Pythagoras special case. When the cosine is 90. This is 0. This is what? 0. Because cosine 90 is 0. R equals square root of t either by m or in terms of m or mg, no matter. Okay? So 5.747, sorry. 5.47, right? 5.47 m squared plus 5.47 m squared. Pay attention, guys, pay attention. 0.
لا استخدم الأولى.
And I use this. You can use this. No matter. Okay, fine. Look here, please. Look what will I do? I will take 5.47 squared as a common factor.
M plus M.
صح؟ What we will have? 1 plus 1.
مش M؟ حط الM.
فهمتوا شو عملت أنا؟ Pay attention here. I took this as a common factor outside the bracket.
بس أول وحدة.
هم نفسهم. common factor. شو بضل هون؟ هون بضل 1 هون 1 صح؟ فأوفرول هذا شو بصير؟ R equals square root of 2 times 5.47 m.
بس ليه هيك عملت؟
يعني
بس
ما بتقدر تحلها على طول؟
بلا
خذ m as a common factor.
كيف طلع السكوير؟
ليه ناخذ كومن فاكتور؟
عشان تخلص الm square.
اوكي انا امتى وحطيتها بالاخير؟
بصير m square common factor شو بضل هون؟ 5.47 صح؟ square plus 5.47 square. square يعني.
طب هذا كله للتنتين صح؟
للتنتين هلا m شو بتصير؟ هي m. وfind the square root of this one. قديش بيطلع؟ 7.7
7.7
3 m. Okay? Clear?
إذا الآية بعديها
Any question about this? ايش؟
عقدتها ليه
خلص
عملنا
اعمل اللي بدك اياه.
انت ايش عملتي؟
Do whatever you want. Okay guys? Any question? بس خليكم معي. Direction. قلنا دائما بالdirection took this angle مع التيل. Right? Direction. Yes. Took this angle. Yeah.
عشان it's the angle between the tensions.
قديش هاي بتكون؟
تطلع فوق
sin alpha over قديش over t اللي هي 5.47. To find the direction, guys, مرة ثانية تبقوا معي شوي please. If you would like to find the direction, we have to find alpha. We always take alpha with the tail of the resultant force. Okay? Take alpha with the tail of the resultant force. This one. Okay? Sine alpha over. What is the opposite for alpha? T, which is what?
7.7
Alpha equals sine 90 over 7.74 m. طبعا m cancels out. You can find alpha. This alpha 40. Yes.
ليه ما صار الهيد تاع الأبي تاع الريزلتنت فوق؟
دائما cosine rule لا cosine rule head to tail the resultant from tail to head هذا addition of vectors. Okay.
يعني اثنين head to tail وواحدة tail to head.
The resultant دائما tail to head. Okay, fine. Okay, girls. طيب.
عايز اسالك سؤال
Yes. We have inclined plane like this. Okay. Please stop. Please stop, guys. Figure 4 shows two particles P and Q of mass 3 and 2 kilograms, respectively, connected by like an extensible string, right? Initially, P is held at rest at a fixed smooth plane, indicated at where? At 30 degree horizontal. The string passes over a small smooth light pulley A, fixed at the top of the plane. Okay, fixed at the top of the plane. Here there is a pulley. Okay, the part of the string from P to A is parallel to the line of the greatest slope. هذا line of the greatest slope, okay? Line of greatest slope هذا. Okay, fine. And Q hangs freely below A. The system is released from rest with the string taut. Type. Pay attention, please. Okay, now look to this. It's given also this is particle P, which is 3 kilograms, and here there is a particle which is Q, 2 kilograms of Q. This is Q. Okay, guys? Type. Write down the equations of motion P. Listen. Write down the equations of motion for P and equation of motion for Q. Equation of motion including the forces with acceleration, and we have to use a Newton's second law in order to determine the equation of motion. Okay, guys, look now, please. What we have to do, as usual, right? Now, what are the forces? Yes, here, 3G. Look here, 3G downward. Normal. We don't have friction, and the tension went up towards the pulley. Here, 2G. There's no normal tension. It does not rest on a surface. Okay, it does not rest where? On a surface. Yes.
هلا كان في سؤال انه الرod wall lies on top of the rod. يعني
Yes. Any question about this? Okay. Next step.
X, Y axis.
X axis, Y axis. This is the X axis.
Yes.
Right? And this is what? Y axis. Here, they lie where? On the Y axis. Okay? So directly, here what do we have? 3G sine 30. Here 3G cosine 30. Any other forces should be resolved? No. Clear? No any forces that needs a resolve. Pay attention here. Look here, please. Now again, it's not given the direction of motion. We are not given the direction of motion. What I have to do, I have to compare the forces that may cause what? Motion. Look, which forces? Either 3G sine 30 or what? 2G. Either 2G pulls the whole system downward or 3G sine 30 pulls the whole system down the plane. Right? Let's compare it. 3G sine 30. What? 2G. This would be what? 1.5G. This is 2G, so this is greater than. Okay? Clear? If it's not given, I have to compare the forces that may cause the motion. Clear? So what does this mean? You know, 2G will pull the system. Yes. Any question? Guys, any question about this? So where is the motion now in this way? This is the motion. This is what? The motion. As usual, for P, F net up the plane equals what? MA. Right? F net up the plane MA. T minus 3G sine 30 equals 3A. This is the equation of motion of particle what? P. This is the equation of motion for particle P. For a Q, yes, F net where? Down equals MA. So T,
2G
sorry, 2G
minus T.
minus T equals what? 2A. This is equation number 2. This is, listen, again, guys. This is the equation of motion for particle P. This is the equation of motion for particle what? Q. As usual, we have to add them simultaneously. So 2G minus T equals 2A, while T minus 3G sine 30 equals what? 3A. T cancels T, 2 minus 1.5 G equals 5A. So A equals 1 over 10 G meters per second. I can keep it as it is, or I can find it. Okay? 0.5, yeah, exactly.
هذا ب A كله.
هذا B. Hi A we are asked only about equations of motion. B we are asked about what? Acceleration. C we are asked about tension, صح? Yes, tension. Now substitute this in any of these equations, which is this one, which is easy. 2G minus T equals what? 2 times 1 over 10G. So T equals, I think,
17.
in terms of G, دخلها in terms of G. 0.2 1.8
G.
G.
1.8 G.
Okay? 1.8 G. حطينا G in terms of G. No.
بس غلطنا بريد.
طيب خلص هذا السؤال. طيب.
واو سارة.
شرط سارة.
We literally did nothing. We don't care.
Guys,
I'm literally it.
camera is recording.
Welcome to JS.
أنا ما حكيناش بالجايز هذا موضح. طيب D, pay attention. In D, what we are asking D?
Take where in your calculations you have used the information that the string is inextensible.
String is inextensible, so both particles, yes, accelerate at the same rate. And we really like inextensible string, both P and Q accelerate at the same rate. At the same rate. Right. Until now, listen. Everything I think is clear. Now look to part E. Read sound.
On release, Q is at a height of 0.8 meters above the ground. When Q reaches the ground, it is brought to rest immediately by the impact with the ground and does not rebound. The initial distance of P from A is such that in the subsequent motion, P does not reach A. Find the speed of Q as it reaches the ground.
Okay, let's discuss this. And actually, listen, guys. We in the previous time we did simple demonstration about this question. You know when Q reaches the ground, what will happen to P?
It will rise.
Yes, it will continue in its motion forward or up the plane certain distance, okay? Then it will stop. Okay? Yes, هلا خلينا نشوف yeah, exactly. Helen, we'll talk about this now. We'll talk about this. Guys, listen. Look at this, please. Pay attention. If this descends 0.8 meter, right? Be careful. This thing is inextensible. So if this descends 0.8, this will move what? 0.8. Right? Clear? The subsequent motion of this, it will continue moving up the plane until it comes to instantaneous rest. Yes, at maximum right height. Okay, fine? Yeah, so actually هنا رح نحكي عن two stages. Stage 1, stage 2. Here the string becomes slack. Anyway, let's find E E, we need the speed where?
Before it hits
Yes, before it hits the ground. So, A is what? 0.98 meters per second square. U0, it's given in the question. S is what? 0.8. So V squared equals what?
U squared.
U squared plus 2AS. V squared equals 0 plus 2.98 times 0.8.
T equal 1.25.
1.25 meters per second. This is what? V. This is V.
Just the initial.
Okay. Have you done? Pay attention, please. Question 7, January 2013. Guys, question 7, January 2013. Similar to this, look here, please. We have inclined plane. We have what? Inclined plane like this. This angle is alpha, right? At the top of this inclined plane, we have an object, a pulley. Sorry. At the top of this inclined plane, we have a pulley, and here, guys, pay attention. This is A. Okay, this is A. A has mass 2m. Okay, has mass what? 2mg. Here there is H 4mg. This is B. Okay, this is what? A. The coefficient of friction is given, mu equals 1/4. Okay, the string passes over what? A smooth pulley fixed at the top of this what? Plane. Okay, this height is h. This height is what? H. The first part of the question, give a reason why magnitude of the acceleration of the two particles are the same. Then the string is NH is inextensible. Like an extensible string A, the string is light and what? Inextensible. If the string is not if the string is inextensible, the acceleration for both particles is the same. Type B, if it's extensible, the acceleration will be the same. Okay, what we have to do now, we have to write the equations of motion. In order to write the equations of motion, again, what I have to do, axis. This is the x-axis. This is what? Y-axis. Guys, this is x-axis, and this is what? Y-axis. What we are given here will be tension always towards what? Pulley. And the tension here towards what? Pulley. Okay, tension towards what? Pulley. What else? Here, direct, we have 2mg sine alpha. Here, 2mg cosine alpha. Okay? بس يا شام 2mg
ما تحركتش عارف تحت امي اصلا.
والله سوري. اللي بتحكي هاي اللي جاب شام.
بدل بدالك ان شاء الله.
Listen, normal this way. Okay. Now where is the direction of motion? It's mentioned, right? For the motion until B hits the ground. B hits the ground. So the motion in this way. And actually it's very clear here what we have. 4mg here, 2mg sine alpha. Okay? So the friction where? Motion this way, the friction in this way. Clear? Any question about this? We are given tan alpha. صح? Tan alpha 3 over 4. Direct حكينا هاي alpha 3 4 5. We will use this triangle in order to find sine and cosine. We have to write equation of motion for A, equation of motion for B, for B. For A, خليكم معي please. If net where up the plane equals what? MA. T up the plane minus 2mg sine alpha minus what? Friction equals what? 2ma. 2ma. Clear? Again, T up the plane, so it's positive. 2mg sine alpha and F negative because they are where? Down the plane. We have to find the friction. We have to find what? Friction. Friction equals what? Mu times R. Mu is given. R equals directly what? 2mg cosine alpha. Right? R equals 2mg. 2mg cosine alpha. Substitute this here. So T minus 2mg sine alpha minus, instead of sine alpha, yes, look, sine alpha, sine alpha, opposite over, yes, 3 over 5, hey. 3 over 5, high sine, minus mu 1/4, guys, look, mu 1/4. Normal 2mg cosine alpha, look, 4 over 5. Cosine alpha adjacent, right, over what? Equals what? 2ma. This is the equation of motion for which particle? A. صح? This is the equation of motion of particle A. I can simplify it as T minus 2 times 3, 6 over 5 mg. Sorry, I multiply, sorry. This is multiplication, okay? 1/4 times titla minus 2 over 5 mg equals what? 2ma. This is equation number 1. Now, for this one, just a moment. For B, F net downward equals MA. Roger? طب واحدة
لا
شو معنى؟
تفهمين بس انه انت تسوي.
طيب F net downward ايش عندنا downward؟ لأنه هذا يعني was done before. يعني it's very simple. ايش عندنا هون؟ الموشن وين؟ downward. فعندنا 4mg minus T. 4mg minus T equals 4m times what? A. This is the equation of motion for what? For B. C, what we are asking C?
Find the acceleration.
Find the acceleration. Add these two equations simultaneously, right? Add these two equations what? Simultaneously. So, T minus, we can add these, 6 minus 6 minus 5, minus 6 minus 5, minus 2, minus 8 over 5 mg equals what? 2ma. 4 mg minus T equals what? 4ma. Add them. T cancels T. 4 mg minus 8 over 5. 12 over 5 mg
Equals 6 MA.
equals 6 ma.
A equals 4.83,
Which is 2 over 5, right? 2 over 5 g meters per second. Equivalent to
3.92.
90. And we will use it now as Farad. Now the third part, or the fourth part, which is important. تيجوا معي على fourth part. اللي هو D. طيب بس خليكم معي شوي. Guys, again, تيجوا معي بس pay attention please. Pay attention for one moment. Pay attention please. Here. If this particle B descends H, A will move upward by H, yani A here. This distance is what? H. Pay attention please. Then, when B reaches the ground,
It does not rebound.
yes, the tension now is no longer acts where on A. So the string becomes slab. The string becomes slab. So the tension now is no longer acts where on A. The subsequent motion, the particle will not stop immediately. So it will continue. Yes, upward for a certain edge distance until it comes edge to 0. What we are asked to find?
Distance x, y.
Yes, distance. The whole distance. What? Right? The whole distance. This is stage 1. This is what? Stage 2. Because after this point, there is no tension, so we have to calculate a new acceleration. We have to calculate what? New acceleration. So here I have to divide the motion into 2 stages. Stage 1, stage 2. Stage 1, look here please guys. Stage 1, what do we have? We have 2 mg sine alpha. Let me complete this please. Tension. Normal, 2 mg cosine alpha. With motion where? Upward. In stage 2, what do we have? This particle without tension, we have only 2 mg sine alpha. We forget the friction. Seen on friction. صح؟ هون عندنا 2 mg cosine alpha normal. Okay? What I have to do here?
Find acceleration.
I have to find what? New acceleration. Here I have to find the final speed. Then the final speed here will be what? Initially. طيب. V square equals U square plus 2AS. Pay attention please. V square equals U square 0 2 in A 2 over 5G with SH. I will keep them as they. طلع معي شو please. So V square equals what? 4 over 5GH. I will keep it as it is. V square equals 4 over 5 what? GH. U square here will be what? 4 over 5 GH. V 0. We need the displacement in the second stage. So, in terms of H. What I have to find? New acceleration. F net up the plane equals what? MA. Minus 2mg sine alpha اللي هي ليش قلنا sine alpha 3 over 5 صح؟ والريفليكشن طلعناه هيو. Reflection will not change, right? هاي reflection will not change اللي هو راح يكون 2 over 5 mg صح؟ هاي friction هاي okay equals كم؟ 2 ma.
M cancels out.
Yes, m cancels out. ليش بيطلع a minus 9.8 صح؟ أو 4.9 negative 6 over 5 G صح؟ 6 over 5 hash G. هلا now we have acceleration. Right? We have what? Acceleration. U square, V square result. V square equals U square plus 2AS. We need S. V square 0. U square هي جاهزة 4 over 5 GH plus 2 P minus S. هذا بتكملوها صح؟ بيطلع معنا مين؟ S. طيب. Anyway, check the answers. Okay? Check the answers. this truck goes a car like this, okay? Here we have tow bar, okay? Tow bar. 170 truck of mass 1,750 kilograms is towing a car of mass 750. So here we have weight 1,750 G newtons. Here 750 what? G newtons along a straight horizontal road. The two vehicles are joined by a light tow bar which is inclined to an angle theta. Which is inclined to an angle what? Theta. The vehicles are traveling at 20 meters per second and they enter zone where speed limit is what? 14. The truck's brakes are applied to give a constant braking force on the truck. The distance traveled between the instant when the brakes are applied. Yani the initial speed is what? 20 meters, right? The system of two particles was moving at 20 meters per second. Then, to reach the speed limit, final speed, which is what? 14 meters per second, a brake is the brakes are applied to give in a constant braking force. The distance traveled is 100 meters. To slow down from what? 20 to 40 meters per second. Find the deceleration. Okay. So here we have to use what? Equations of motion, right? We have to use what? Equations of motion. V squared equals U squared plus 2AS. V squared equals, V squared is 14 squared, right? Is what? 14 squared. U squared, 12 squared. 2A times S, which is what? 100. A equals
negative 1.02.
Negative
1.02
meters per second square. Negative because it's deceleration actually, right? Okay. Secondly, what we are given, the constant braking force on the truck has magnitude R, right? The constant braking on the truck has magnitude R. The braking force will be where? Opposite what? To the motion, right? In order to slow it down or to stop it, okay? Also the truck also experiences a constant resistive force of what? 300. Here also we have a resistive force which is 500, newtons, okay? Here we have a resistive force of what? 300 newtons, okay? This is a friction or overall resistive force. We are given that cosine theta equals what? 0.9. What we have to find? We have to find the force in the tow bar and the value of R. The force in the tow bar, yes. Okay guys, pay attention here. Here we have what? Deceleration, right? Here we have deceleration. In deceleration, if you remember, yes, the force in the tow bar is a thrust. And this force would be like this. Look here, please. Here we have thrust from the car. Here we have thrust from what? From the truck. Okay? Thrust from the car, and here thrust from where? From the truck. Why? Pay attention below. Again guys, let's use the concept or the flavor of the physics in order to explain this. Okay, now the braking system are applied where? Guys, pay attention here. The braking system are applied where? On the truck. The truck decelerates, right? From what? 20 to 40. Why? The car stays moving where? Forward with the speed what? 20 meters per second. Because the brakes are applied on the truck, not where? On the car. This is what is mentioned in the question. So if the car is continuing its motion forward by 20, it will apply force or it will push the tow bar in this direction. صح? It will push the tow bar where يا شام? In this direction. As a result of that, the truck will push the car where? In the opposite direction. Okay? Again, this is the truck and this is what? The car. The truck decelerates, but the car is what? Continuing its motion where? Forward, right? Because the brakes are applied only on the truck. What will happen now? The car will push what? The truck forward by thrust. As well, every action has equal and opposite what? Reaction. The truck pushes the car through the tow bar where? Backward. And as what we mentioned before, directly, even if you don't like to think in this way, always in the tow bar, in case of deceleration, we will have thrust in this way.
So does only take into account the tension?
It's not tension here, it's a thrust. If it's accelerating, it's what? It's tension. Okay, now, what we have to do, I have to resolve the forces or deal with, let's use a Newton second. Look here, guys. Look. If you remember, this force should be shifted where? Here. This is the thrust. Okay? Why? Because always, we will deal with forces that their tail on the object. Their tail where? On the object. Okay? Fine? And I have to shift this force here. Same thing. By the same angle. What is this angle?
15. No.
Theta. So this is theta. And this is as well what? Theta. Z. Okay? So this angle is what? Theta. Here, this force will be shifted where? Thrust. Okay? Clear? This angle is also what? Theta. To simplify things, I have to redraw everything. Thrust, theta, normal, right? Weight, which is 1,750 G. Okay? Braking force R, resistance what? 500 Newton. This is for what?
Truck.
For truck.
It says you modeled it as a particle.
Yeah, definitely. We will. In M1 in mechanics, all bodies will be modeled as a particle. Okay? Best in order to simplify things, I have to redraw free body diagram this way. Always again, guys, if the tip of the force, pay attention, girls. If the tip of the force lies on the object, shift the force in order to have the edge, it stay where? On the object. So I can resolve everything easily. Now what I have to do, resolve this force, right? Here, thrust cosine theta. Here, thrust what? Sine theta. Okay, thrust sine theta. Here, R. Any question about this? Okay, equation of Newton's second law, equation of motion F net forward equals what? Ma. Thrust cosine theta minus R minus 500 equals 1,750 times the deceleration, which is what? Minus 102. How many variables here? 2. Thrust, R. Thrust and R, right? Cosine theta is 0.9. 0.9 the thrust minus R equals. Move this here.
زين ورزان
زين ورزان تقامينا
ضحى ملك ريمان ملك وريمان مش ريمان سوري نهى سوري والجاي وانا ايت
guys, fine? So here what we have to do, 0.9 minus, 0.9 thrust minus R, move minus 500 here, what we will have?
Negative,
Minus 500 on the other side,
negative 1,285.
negative 1,285.
285.
This is equation number
1.
1. Okay, this is equation number 1. For the car now, for what? The car. I will redraw also the free body diagram, okay? For the car now, look, we have thrust in this way, okay? Thrust, normal. This is the car, right? Thrust in this way, this angle is what?
Theta.
Theta. Weight 750 G. Normal force upward and what?
300.
300 newtons, which is what?
Resistance.
The resistance, okay? This way. These are the forces that are exerted what on the truck. Okay. Thrust, we forget to add what? Normal sign. Here in a normal, here as well, I know. So here thrust, 750, 300 normal. What I have to do now, I have to resolve what? The thrust. Here we will have thrust,
Cosine theta.
cosine theta. Here thrust,
Sine theta.
sine theta. Okay guys? So now, F net still forward, still what?
Forward.
Forward equals what? MA. Do we have any forward force?
No.
No.
Negative.
Negative thrust cosine theta, right?
Negative
Minus 300 equals, no any other horizontal forces, 750 times minus 0.2.
Does this one?
Shilin now.
So, thrust cosine theta equals 465.
Thrust cosine theta اللي هو
0.9.
yeah.
تطلع 465. لا أستاذ positive. already أخذت النيجاتيف.
خدت negative.
تطلع 465.
465. Okay. We do it. Okay. Now substitute this here.
لا مش ضروري عشان يعمل substitution على طول.
ما احنا
هي 0.9
نطلع وعوضه هون مكان 0.9
بيطلع 1750.
كم؟ 465 minus R equals minus 1285. فهذا الأخير قديش بعطيني R؟
1750.
1750 newtons. Be careful guys. إنه هاي R مش normal. خلينا بلاش تفكروها normal هاي. نكتبها normal force. Normal. وهذا ايش؟ normal.
صراحة أنا النورمال R small مش capital.
No matter, just the definition, right? Just the definition.
طب أستاذ thrust.
هلا thrust, hey, we found this, صح?
51 500
0.9 thrust equals 465. Is in thrust
517.
517 newtons. Okay, fine? Clear? This question, the main point in how to deal with a tow bar that for the system of two particles that are decelerating, okay? System of two particles that are or those two particles are decelerating. بعدين تعمل هذا الشيء. هذا similar to June 5. Similar to June 5. Figure 4 shows a lorry of mass 1,600, right? 1,600. Okay, weight. Towing a car of mass 900, right? 900 kilograms. Sorry, 900 weight, 900 G. Along a straight horizontal road. The tow bar is inclined to the horizontal with 15 degree by 15 degree. Okay, the two vehicles are joined by light tow bar, which is an angle 15. The lorry and the car experience a constant resistance of motion of magnitude what? 600, 300. Here,
600.
the resistance here is 600. Okay? Resistance here is what? 600 Newton. And the resistance here is what? 300 Newtons. Respectively. The lorry's engine produces a constant horizontal force with 1,500 what? Newtons. Find acceleration tension. Here guys it's accelerating. Here it's what? Accelerating. Since it's accelerating, accelerating. Here we don't have thrust, we have what? Tension. Similar to what? To the string, similar to string. Look here please. Here the tension here in this direction and the tension here in this direction. Okay? Tension here this way and the tension here in this way. What you are asked to find? Tension and acceleration. Okay. As usual. Look here please. Yeah, we have also what? Normal force here and normal force where? In this way. Guys, pay attention please. For this particle, weight 600 G. Here we have 1,500 newtons. Here we have what? Normal. Tension would be in this way. Magnitude of what? 15 angle. Also we have here what? Friction, which is 600 newtons. 600 what? Newtons. Similarly, here, look. We have tension this way with angle 15. Pay attention guys. Resistive force 300 in this direction. Weight, which is 900 G. And normal force. What I have to do, I have to resolve what? Tension. Here, T cosine 15. Here, T what? Sine 15. Here, T cosine 15. Upward we have what? T sine 15. Clear? Any question about this? Now, as usual, we will use a Newton's second law to write the equation of motion for each particle. For F net forward equals ma 1,500 minus t cosine 15 minus what? 600 equals 1,600 A. Here, F net similarly forward equals ma. T cosine 15 minus 300 equals what? 900A. This is equation number 2. This is equation number 1. That can be done simultaneously. Okay? 1,500 minus 600, 900. Minus t cosine 15 equals 1,600A. The second one, t cosine 15 minus 300 equals what? 900A. Look, easily, simultaneously, these will be cancelled out. Right? Eventually, what do we have? 600 equals 2,500A. So A equals 24 meters per second. If we found A, we can substitute A either in equation 1 or 2. We can find what? The tension. So this becomes 900 minus t cosine 15 equals 1,600 times A. 0.24. So tension equals
534.
T equals 1,000.
534.
500, sorry,
34.
34 newtons.
Three significant.
Yes, 534 newtons to 3 significant figures. Clear?